Okay, in this presentation we are going to look at the Weibull distribution. Specifically, we're going to look at how to derive an expression for the median of the Weibull distribution. Now this one is sort of straightforward enough because what we're going to do is follow a set of steps that is very much corresponds to every similar exercise where we calculate the median for a different probability distribution. So the key thing there that we have to work with is the cumulative distribution function. So we have to state the cumulative distribution function, the CDF of the Weibull distribution. Here it's given by f of t equals 1 minus the exponential of t divided by lambda to the power of t. So minus t divided by lambda to the power of t. Now just watch the brackets there, where lambda is the scale parameter and k is the shape parameter. Okay, so that's the first step, and the second thing we have to do is just define the median. The median m is the value of t such that f of m equals 0.5. Okay, so essentially what we have to do is that the cumulative distribution function of m, and just express that cumulative distribution function in terms of m and let that equal to 0.5. So we have 0.5 equals 1 minus the exponential of minus m divided by lambda to the power of k. Okay, so again, just watch the brackets there. The power of k refers specifically to the fraction of m divided by lambda. Okay, and after the fact, we get the negative of that. Okay, so yeah, we'll move on. So that expression should simplify fairly quickly in some respects. We have 0.5 equals 1 minus. Essentially what we can do is just actually let that equal to 0.5. Okay, so rearrange the equation to isolate the exponential term. So essentially what we want is just rearrange it algebraically. So we end up with the exponential of minus the fraction of m divided by lambda to the power of k. Let that equal to 0.5. So what we're going to do is take the natural logarithm of both sides. Okay, so when we get the logarithm of an exponential term, we end up with the argument of the exponential term. So we end up with minus m divided by lambda to the power of k, and that is equal to log of 0.5. Now just remember the rules of logarithms here. Okay, so recall the rules of logarithms. Log of x equals 1 is equal to minus the log of 1 over x. And in fact, you can work that the other way around. Log of 1 over x equals minus log of x. Okay, so we can re-express this as follows. Minus m divided by lambda to the power of k equals minus log of 2. Obviously we can remove the negative signs of both sides. M divided by lambda to the power of k equals log of 2, and essentially we raise both sides to both sides of the equation to the power of 1 over k and solve for m. So m divided by lambda equals log of 2 to the power of 1 over k, and we just cross multiply. Okay, so just looking at the second term there, we have m divided by lambda to the power of k. When we raise that, we just get m divided by lambda on the left hand side. On the right hand side, we have log of 2 to the power of 1 over k. So essentially we just cross multiply both sides, or cross multiply by lambda. So we end up with m equals lambda times log of 2 to the power of 1 over k. So that is it. Therefore, the median of the Weibull distribution is m equals lambda times log of 2 to the power of 1 over k. Okay, so the median depends on both the scale parameter lambda and the scale parameter lambda and the shape parameter k of the Weibull distribution. Okay, that's it. We'll leave it there.